Hey, we are live. Hi, everyone. This is Marcus. I work as a developer relations professional for Edge and Node, one of the core dev teams building the graph. And we've got three Subgraph developers working with Messari today. We've got Chris, Dhruv, and Harsh. And I know we're a few minutes early before the workshop is to start, so we're just going to hang out and chat. So, Chris, Dhruv, Harsh, how's your days going today? What have you been up to so far?
You're
Oh,
on mute,
yeah,
Chris.
Chris, we got you muted, buddy. We're live.
Yeah, my day's been going great. Um, Leading up to this, I have just been doing some DBT modeling and preparation for this presentation.
Awesome. Drew, what about you, man?
Yeah, so far so good. So doing the things that I do every day, developing subgraphs. So right now looking into Gearbox protocol. So pretty interesting leverage trading protocol, doing some good numbers. So yeah.
Awesome. Awesome. And Harsh, what about you, man?
Uh, so far, so good. I'm building Substream right now for
Oh, nice. Nice.
yeah. So
Harsh,
I'm
your
looking at
microphone's a little
Substreams.
bit quiet. Is there a way you could turn up your microphone a little bit?
I'm not sure. Let me check.
Sure. Awesome.
Yeah, a little bit of context. We've actually all been developing subgraphs together for a little over 2 years now.
Awesome.
Since when was it? Like May 2022 or so?
Oh, that's awesome. That's
Yeah.
awesome. Yeah, May of 2022. It's
Yeah,
around.
together over the last 2 years, we've built close to 150 subgraphs, standardized
Y-
subgraphs.
Your team itself, the three of you together?
The three of us have built most of the subgraphs between us, but we've had subgraph developers come and go over the years.
That's awesome. That's awesome.
Hmm.
Yeah. So 150 for those of you in the audience, building 150 production subgraphs. Um, More power to you guys. More power. I'm actually curious on the maintaining and updating and management of that. I'm curious how that strategy goes. I know we're going to be talking about more DeFi techniques and
Hmm.
dynamic data sources today. However, I'm just the business of managing the management, if you will. So one step back from being in the code. But anyways, yeah, we'll keep on chatting here for a minute or two. Let people filter in to the stream. For those of you just joining, hi. We're going to be going with three Subgraph developers who are working with Messari. It's a core development team that is building the graph. And for those of you who don't know, Messari builds standardized subgraphs that are incredibly powerful, that have a lot of professional qualities just baked right into them. They've done a lot of thinking, a lot of work. And I just found out from Chris right now, they have built, between the three of these gentlemen in front of me, about 150 subgraphs that are in production right now. So the level of experience here is significant. So we're in for a treat. Um, so yeah, guys, we'll go for about one, maybe two more minutes, and we'll go from there. Any questions, please drop them in the chat. Let's see. Da-da-da. Always multi-window. Do you guys have a multi-window setup?
Yes.
Yeah. How many windows we got going on?
So recent up until recently, I did have a two monitor setup, but then I just quit the two monitor setup, got myself a 43-inch big ass screen. So it just solves all of my window problem.
There you go. There you go. All right, I'm looking at the chat right now. I got all the chat windows open. Anyone who's watching, please drop questions into the chat. I'll be happy to ask them. The questions will be asked at the end of this workshop today. And for now, we'll let everyone who is here from the Messari team take the stage. But before they do, I want to make one quick announcement. At the hour, we're starting at the hour. I'm on Eastern Standard Time. It's 12 p.m. here. That's 1 hour from now. It's 1 p.m. for me. That'll be 5 p.m. UTC. There's going to be a core dev meeting that is going to be open to the public. And there's some really cool announcements that are going to be going down during that core dev announcement and presentation. I'll drop that into the chat for everyone who is not aware of that, but if you guys can see here, this is the core devs meeting, and it is going on today in 1 hour. And there's the Zoom link, and feel free to hop in and learn about this agenda. We've got an update on Graph Horizon, an update on Subgraph data service, and then also a new Substreams code gen. That's really, really cool. So for those Substreams developers out there that want to understand how easy it can be potentially to spin up a Substream, that code gen is going to be big. And then also updates on indexing fees and graph node features. This one I really like, subgraphs as data sources, where essentially we can now have subgraphs being composable, where we could plug one subgraph into another. That is coming in graph node, which is really, really cool. So that is all the announcements I'm going to go over. I'll drop this link into the chat, and I will step off stage and let my guests hop on. Let's see, stop sharing. Where's the button here? Okay, perfect. All right, so Messari devs, go ahead and take over. Looking forward to this workshop with you and learning from you guys.
Right. So thank you, Marcus. Thank you for the introduction. So like he's already told everyone, so we are builders at Messari. So Chris, Harsh, and I, so we have been working on subgraphs for a little over 2 years now. Together with other builders, other subgraph wizards at Messari, we have built in total around 150 subgraphs. These subgraphs are like multi-network subgraphs. So in total, Messari has some 600 deployments for subgraphs hosted. So yeah, today the motive of the call is to share with you a little bit about the Messari way of building subgraphs. So we'll try to cater to both type of audience, the audience who are looking to consume data from these subgraphs as well as the subgraph builders. But this will be more aligned towards the builders, and we will talk more in depth about the tooling and specifically the pricing library that we have created in-house and has helped us tremendously. And right, so I'll get to that in a bit. So before we start, I just want to give a brief overview of what the project is and like how it just came into existence. So I think it was back in May 2022, like somebody, Chris just reminded me right now. So yeah, Graph and Messari had this collaborative effort to build these really extensive subgraphs, which had both horizontal and vertical coverage, meaning that they would cover all sorts of DeFi categories, ranging from DEXs, the bridges, the CDPs, the perps, and options, all sorts of these categories. And in depth, meaning that they would go into the very minute details of the kind of metrics that each of these categories should and uh, can index. Right. So the aim for us remains to just grow on the kind of coverage we can. So we are continuing building more and more subgraphs each day, each month. And if you have requests for the protocols that you want to add a subgraph for, just let us know. Right. So with that, I will start the presentation. I will just present my screen. Right. I hope you guys can see. So anybody who's just wanting to learn about the Messari subgraphs or want to get into the project, the single source of entry will be our GitHub. So just type GitHub Messari/subgraphs and you're in the repo. So first I will talk about the data consumers. So how data consumers can essentially use the repo, use our subgraphs to query on the graph and build all sorts of things, like ranging from their own analytics dashboard to using these as triggers to do certain DeFi things on their own. Right, for the data consumers, I would recommend when you come to the repo, you would notice that there are right. So there are two kind of things that you want to understand. So one is what subgraphs, what protocols have we covered so far, and within that those protocols, what kind of data are we indexing? So just to get a list of the subgraphs. So there are multiple ways, but like just a simple way is to go inside the subgraph folder, and here you'll get a list of all the protocols that we have covered so far. So here you'll get all the Aves and balancers, the Binance Stake Deep, for instance, Compound, uh, and you get the idea, right? So it's like a lot of protocols, but you can scan and see if the protocol that you're interested in is here. The next part, just to understand what kind of data these subgraphs store, I would point you to the schemas. So these schemas are built by the Messari researchers. So they are very in depth, and these try to cover every possible metric that can be uh, observed from these subgraphs. So for instance, we'll just take any of these schemas. So let's say we're interested in perp future schemas. So I'll just open that up. So since most of you guys are already subgraph builders, so I would not really go into the details of how to create entities, how to attach these entities together, how do they work together. Rather, I would just give you an overall picture of what what the generalized schema pattern is. So in the generalized schema pattern, we try to create one parent entity, which we call as a protocol. Inside that protocol, we have a couple of individual entities which are called pools. There are also account entities which interact with these pools, and there are some token kind of entities which represent the input and the output tokens of these pools. At each stage, at each of these entities, the protocol, the pool, the token, the accounts, so we store a whole bunch of information that we can about that. So I'll just give you an example. So we'll just go into the protocol entity. And if you just notice, so we have created a protocol entity, and inside the protocol entity, we are storing all sorts of quantitative data ranging from TVL, the volumes, the revenues, the premiums paid by the users, the number of unique users, number of depositors, borrowers, the open interest, the position counts, and you get the idea, right? So it's very extensive, and like it covers all sorts of data. Similar is the case with the pool and the accounts. So we try to go in depth with all of these schemas. Right. So after you're done with the schemas, uh, you can actually look at the deployed subgraphs that we have deployed on the Graphs decentralized network. To do that, just go over the graph.com/explorer. Once that opens, in the search by Messari as creator. And under there, you'll find all the subgraphs that have been deployed by Messari, right? So it says 9,000 subgraphs. Nice. Right. So for this example, we'll just pick any of these subgraphs. So let's say we'll look into the GMX Arbitrum subgraph. So I'll just open that up. Now there are a couple of ways to query the subgraphs, right? So if you're just looking for a quick query and want to check the data that this subgraph indexes, so you can just write the query in the playground offered here. So let's just write an example query saying, get me the positions which are where side is long. And for these positions, we want to find out the transaction on which these were open, the transactions on which the position was closed. Let's also find out the collateral balance posted by the user, as well as the leverage taken during the trade, right? So here, so we get a list of positions which have all of these. So we can go more in depth. We can filter these by, let's say, the block range. We can order it in ascending, descending order, filter it by the amount of collateral, and all sorts of those things, right? But you get the idea, right? Another way to use this is via API. So the graph will give you the API key that you can directly query. We have also developed some tooling that lets us chart these time series data for these values. So how to get there is using the deployment key, copy the deployment key, open a tool called OKGraph. In the last builders hour, Yash talked about OKGraph. So it's a very useful tool. What it does is if you give it a subgraph ID, it gives you the information about the indexing status of the subgraph. So it tells you when those subgraphs started indexing, how much it has indexed so far, what was the last block of the indexing, what is the progress of the subgraph so far, and the health, and if it's synced completely or not. Uh, Here in the links, you would notice there are a couple of links, like you can check the logs directly from here. But what I want to talk about is the Messari visualizer. So Messari visualizer is a charting tool that we developed. It's mostly for internal usage, and I would not recommend using it in production environments. But either ways, it's a tool which lets us chart these entities that we collected from the indexer as time series data, and also is very beneficial for us for queuing and data verification purposes, right? All right, so if you look at the Arbitrum, so these are the current protocol metrics. Like if you notice, the total value log will be around 76 million. The volume is 121 billion, I think, and all of those. But what is interesting is, so we have this chart of time series data for each event that has occurred in the past, right? So here you get the total value log, the volumes, these are the volumes, inflow and outflow volumes, and then the open interest, the funding rate, and everything, right? So yeah, the point I'm trying to make is that these are really extensive subgraphs and like try to capture a lot of metrics which the tools that are out there do not directly offer, or offer at a very high price, right? And we are trying to make this open source for data collectors to use the subgraphs as is. Cool. So I hope data collectors find this helpful. So I'll just transition to the data creators now, the subgraph developers, right? So for the developers, again, the single point of entry is the GitHub repo. Go to the GitHub repo. For developers, I would recommend just going to the docs first and reading a very important documentation that we have written. It's called walkthrough.md. So walkthrough is basically a step-by-step guide of starting from zero to ending up creating a subgraph in Messari and like deploying it to the network, right? So I am not going to go into the details of each step because this is very well documented with all the links that you would need. So I would definitely emphasize again that you should start from here. Right. So once you're done with this, another important doc that I want to point out is the tooling doc. So over the last couple of years, so we have tried to develop more and more tools which will aid developers to build the next set of subgraphs quicker and easier, right? So I will just point out what the tools are, where to find them, and what they do, right? So the first one is called the Messari Subgraph CLI. So Messari Subgraph CLI is nothing but like a wrapper on Graph CLI. So it lets us do the basic function of Graph CLI, like the code gen, build, and deploy. But it also lets us do some templating that we have set up, in which which basically lets us not repeat code for multi-network subgraphs, if you get that. Right. So this is one thing that you have to install before running this Messari subgraphs on your own, right? So if you're looking for to where to find it, so it's in the Messari organization. You go and you find the subgraph CLI. All the installation instructions and like how to run it are written in the README. So you should be able to run it in no time. Right. So next up is the subgraph.xyz, the dashboard that we just talked about. So this dashboard just lets you chart and visualize and helps us in QA and data sanity, right? Another tool that we have seen right now, just now, is OKGraph. OKGraph, you input the graph ID, it gives you the graph status as well as the links to the visualizer and logs. Right. Another tool, interesting tool, is called the logging dashboard. Uh, most of the people have had problems with logs in the past when they deployed their subgraphs on the hosted service or even the studio. When the logs are not really persistent and sometimes missing. So what we created was to build an in-house logging dashboard where you can just uh, give it a subgraph ID and it will collect all the logs and make them persistent, right? So you can just return at a later point and try to filter those logs by uh, uh, and try to find whatever you wanted to. It's a access only, so if you need credentials, please ask. Right. So another interesting tool is Miniscan. So Miniscan is a block explorer, but like a multi-chain minimal block explorer, where you can just enter the contract address, the networks it is deployed on, and this lets you do the function calls as well as gives the deployment address, deployment details of the contract, like uh, the starting block of the contract as well as the ABIs of the contract, right? So it is helpful when you're doing protocol research and do not want to really go into the Etherscan, do like multiple steps of switching tabs to code and then going in the function detail, calling that. Uh, right. So it's just everything you need to set up a subgraph in one step. The last one I want to talk about is the status endpoint, and another mention is the monitor tool that we have. So status endpoint is like a single endpoint exposed, which lets us know all this current status of all our deployed subgraphs. This is utilized by another tool called Monitor Tool. Monitor Tool just watches for this status update and lets us know if there are subgraphs which are lagging behind in syncing or have some indexing issues, and updates us on like channels like Slack and Discord. So like we can proactively take steps to fix those issues. Right. So those are mostly all the tools that you would require. So once you're sorted with tooling, I think then it's pretty much time to dive into code. So for this tutorial, I will just try to update an existing subgraph and rewrite a function that the subgraph already has. And right, let's try to do that first and see where it goes. Sure. So the first things first, go to the subgraphs repo, create a fork. I have already created a fork, but you create a fork before cloning it. So create a fork, then clone it. Once you clone it, so I'll just do a get clone, and then I have this fork. Give me a minute. Right. So once it's forked, go inside the subgraph folder. You can do a ls and see all of those things that we saw in the repo. You have all the schemas, you have the subgraph folder. For now, we'll just go into the subgraph folder. For this demonstration, we'll be changing one of the GMX handlers. So we'll go into the GMX subgraphs. We'll look what the GMX subgraph looks like. So it's modeled as a fork. So there's some common code between GMX and one of its fork called Mummy Finance. But we're just particularly looking at the GMX code. So anyways, we'll just open it in our VS code. Right. So uh, like for the people who do not know what GMX is just a perpetual exchange in which there are two sides of users. One are called traders, the other are called liquidity providers. Traders can spot trade or open leverage positions, and liquidity provider essentially take the opposite side of these trades and earn rewards when traders lose, essentially, right? And lose when traders win. Right. So the structure is simple. Again, I'm not going to go in much detail about how to set up subgraphs. Like Graph has a lot of those resources, so I would just point you out to the Graph README. Anyway, so we'll go into the GMX and uh, we'll look uh, we'll look at the handlers that the GMX has. So a little overview. So MLP GLP managers are the contract where the liquidity provided by the liquidity provider resides, right? So before we start anything, we'll just go back to our fork, do a quick npm install. So npm install just installs the graph CLI, graph TS package, and like for your internal use also installs the prettier package. Right, so once that is installed, and then we will utilize the Messari CLI now. So this is a build command. So it's you could either say Messari build gmx arbitrum -l flag stands for logs. If you don't say -l, I'll just return the final output. So I want logs also. So there is a chain of how the Messari build commands templates uh, multi-network subgraphs, but today that's not the topic for today. We'll cover that in some other day. So for today, we'll just use Messari CLI if like it works, right? Cool. So if you go into the subgraph.yaml, so it has created a subgraph.yaml for us from the template that we had given it, right? And in the subgraph.yaml, you see there are a couple of contracts. So it's three actually. One is called Vault, one is called GLP Managers. The Vault is where the traders actually deposit and remove liquidity from. The GLP Manager is where the liquidity providers deposit and withdraw money from. Right. So for the purpose of the demonstration, we'll just be changing one of the handlers of GLP Manager contract. So we'll go into the MLP manager file. We'll remove the existing. So we have already created a transaction helper method which internally manages all of that. But today we're going to write this down on our own, right? So first steps first. So we first want to check what all is provided in the add liquidity event. So we will just do a event.params, and you will get a prompt saying what all is available in params, right? And we will just put it rename it, like the account becomes account address, token become token address. The asset under management in USDCG becomes the Vault TVL, and so on, right? So the first step now is that we have whatever information, whatever the data that we could get from the event params. Uh, Another step now is initializing the SDK. So now I'm going to talk a bit about what SDK is and like why we developed the SDK. So SDK, the primary idea of the SDK was to abstract the developer from most of the schema related functionality. Uh, so now think about all these entities that we talked about. So the idea is that if you want to update the pool input token balances of a pool, you do not necessarily have to call that on your own and update it, right? We create a black box and we expose certain helper methods to you where you just enter where you can do stuff like just calling pool dot update tvl, and you just give some amount value, right? And this just updates the pool tvl both in the native value as well as the USD values, and uh, and also updates any of those supporting fields, right? Let's say protocol tvl. If a pool is updated, protocol on its own is updated, right? uh, but again, SDK is another topic that we can cover another day. It's a very in-depth topic, but for now we'll just say that we have initialized an instance of a SDK class, and after we're done initializing the SDK, the next thing we're going to do is load a bunch of entities. So we're gonna load a pool entity, a count entity, and a token entity, right? We're directly gonna update pool and account, and token essentially becomes the reference entity between the two, right? Uh, so now, since we're mostly concerned about adding and removing liquidity, so the only parameter that essentially gets changed is the pool's token balances. Uh, now, caveat about the GMX is that it allows multiple collateral deposits and withdrawals. So to manage those, we maintain a list of input token balances for each pool, and for those lists, we create a parallel list which maintains the balances of those pools, right? So every time there's an update in the balance of any of those one token, we have to iterate over the balances, find the index of the token, that index of the token in the input token balances list, and accordingly update the uh, balances list on the same index, right? So this is the code to do just that. So here we check if the input token balance is already present in the list of input tokens. If it's not, then we add that token to the list. And then once we have added that token to the list, we find the index of the token in the input token balances, input tokens, and like accordingly update the balances array on that index, right? So I'm just going to do the imports. Right, so see, there is some, it is imported, all right. Let me just try to recopy. Cool, I'll try to get back to this. Oh, all right, I think I got it. So big int is actually available both as a graph TS, and it's also available in like JavaScript, so it just confuses sometimes between the two, right? So that is resolved now, and we have updated the balances and the input tokens accordingly. The last thing we want to do is like update the financials, and for those we'll use the helper methods provided us by the SDK. So like I explained earlier, we just have to do pool.set token value logged and input the vault TVL, and it will take care of updating all the balances, the USD values, the protocol balances, and the USD values on its own. So it's literally that easy, right? So next up is updating some other financials, like the tokens, output token supply, and the stake token supply. Another thing that we update here is we create a event for this deposit event, and we update the protocol usage based on that. So here we say that number of depositors increases by 1, and the deposit amount has increased by this amount that has been minted for. Cool. So now that we have updated the input token balances and the prices are internally handled by the SDK, I will just go a little over what the SDK internally calls to update the prices. So here you notice all sorts of helper functions. One is called the refresh token value logged. And inside the refresh total value logged, you'll see amount USD, which calls the get input token amount price, gives it the input token list and the input token balance list, and what we get is the list of input amount in USD. Uh, so for this particular piece, for the pricing library, I would let the original author, the first author of the pricing library, take lead. So I'll give the control back to Hirsch. Hirsch, you're
Thanks,
on.
Luke. Yeah. Let me share my screen. I hope my screen is visible to you. Uh, so this is the subgraph wrapper of Messari. now we will check the reference subgraph, which is the main entry point to find the latest price list
Hey, Harsh, real
version.
quick, can you make your screen a little bit bigger?
Sure.
The VS Code is a little bit small. There you go. Thank you.
Sure. So before we get into the price list, I want to first talk about why do we need price list. So the only way to get prices on chain is through oracles, and these oracles, uh, such as Chainlink, supports only a limited number of tokens and is available on a number of networks. Is available on a limited number of networks. So to solve this, we have created a price loop which aggregates multiple oracles, on-chain oracles, and also adds in methods to derive prices from dexes, which we will go through in a little bit. And this is the main entry point of the price list, which is the index.ts file. And in this file, we have all these methods that the price list currently supports. These are the oracles that the price list currently supports, and these are the dexes that price list currently supports. For the purpose of this presentation, I will go through one of them each and explain the working behind these oracles and give a short demo on Etherscan maybe to understand how we use RPC calls to get the prices on chain. So first, let's go to the Chainlink price feed. This is the function for that, and it is in oracles folder. In this folder, we have a function called get token price USDC, which takes in the token address that we want to find the price for, and it interacts with the Chainlink contract.
Real quick, Harsh, I'm sorry. For some reason, it sounds like your microphone's a little bit quieter than we'd like. Unfortunately, can't hear you very well. Could you speak a little bit louder?
Sure.
Yeah, thank you.
Sure. So let's recap. In this price feed, we have a function called get token price USDC, which takes in a parameter called token address, which is the address of the token that we want to find the price for. And this function, we interact with the Chainlink contract to get the price of the token. In the Chainlink contract, we interact with the latest round data function, view function, which is a view function in the contract, and pass in the token address and the constant dot Chainlink USD address, which is something specific for the Chainlink. You can also read about this in the docs. And once we get the results, we divide it by the decimals to get the actual price from the raw amount. Let's look at it on Etherscan and how we can get the price by doing a RPC call on Etherscan. So this is the Chainlink feed history contract on Ethereum, and here is the function called latest round data, and here is the address that I've passed in as a base, which is the address of the STETH token. And this is the code which is something specific for the Chainlink, which we can also read about in the docs. And if I query this, I will get a parameter called answer, which results the raw amount of the token price. And after dividing it with the decimals, correct decimals, we can find the price. So for this, the price should be $2,575. So this much should be divided.
Will you just zoom in a little bit on Etherscan?
Yeah. Sure. Yeah. Cool. Now let's go back and look at the other function, which is of DEX type, the Uniswap Fox router method. So this method is a little bit complex. I will explain it using the Etherscan only. If you want to read more about this, you can go to the repo and look at the code. But for this presentation, I will go through the Etherscan only. So, so there are two methods to find prices in Uniswap. The first method is to use the router directly, and this is the router contract. Let me zoom in. This is the router contract which we can use to find the price of the tokens using the get amounts out function. The router contract in Uniswap is responsible for handling the swaps within the Uniswap ecosystem. So here we need to pass the amount in and the path of the token to get the price. So for example, if we want to find the price of this token, which is the address of the Chainlink token, and the path should be the Chainlink token, then the ETH token, then the USDC address. And the amount in should be in the correct decimals, and it should be the decimals of this contract, which is 18. That's why here are 18 zeros. And if we run this, we will, the last parameter that we will get is the price of the token, of this token in USDC terms. And if we want to derive the price of this token, we need to divide this by the decimals of the USDC address. So the USDC address has 6 decimals. If we divide it by this, we will get $11.2, which is almost quite close to the actual price of the Chainlink token. Apart from this, we have so I've mentioned two methods today. First is Oracle method, and the second one is Dex's method. The Oracle method is a little bit faster compared to the Dex's method because we are doing a single RPC call, whereas in the Dex's we have to do multiple calls to find the pools, then find the decimals, etc. So that's a little bit slower. To overcome this, we have done some optimizations, added an optimization layer on top of this, which Dhruv will talk more about. Dhruv?
Thank you for that, Harsh. So I'm just gonna quickly talk about optimizations and not go into much details. So there are like a couple of times when either the token pricing is broken in between. So let's say the STETH token pricing we have been getting from Chainlink or Oracle, and during a couple of weeks last month, the pricing was off. So there we would want to use another Oracle, but in general, not change the entire Oracle for the entire duration, right? So we have added something called an override. In an override, you can select a token and a block range. And for that particular token and block range, you can set Oracle preferences. You can even select multiple Oracle responses. So you can say that get me prices from both 1-inch Oracle as well as the Chainlink Oracle. And the returned response is actually the average value of those two Oracle prices returned. So this is one kind of optimization. The another one is called liquidity bounding. So when using the DEXs method to get pricing, so what we have faced at times is that there are some meme coins that get rugged, and that instantly just changes the causes the price of the token to spike up. To fix that, what we do is, so for instance, if there's a pool with some 100 meme coins and 1 ETH, and so then each meme coin is valued at 0.01 ETH. Instantly, somebody decides to dump on that. So deposits 1 million meme coin tokens into that pool and takes away all the ETH from that pool, right? So the price of meme coin then is not 0.01 into 1 million tokens, right? The price is limited by the liquidity that was in the pool. So the price of 1 million tokens is limited by 1 ETH, which was the original liquidity in pool. So we bound the pricing of such tokens in this method, which we call the liquidity bounding token. For the end result, if none of this works out, and there are times when none of these methods work out, so we just utilize a plain simple list of blacklisted tokens. So sometimes we just have to do that to blacklist tokens and not consider them in the protocol metrics. Right. So that is all that we have for pricing and for the tooling. So I think now we can take questions if he has anything else to add. please go on.
Hi guys. I was having small UI technical difficulty with Riverside. Awesome. Thank you so much for sharing the
Right.
details on. I like the path. We followed the path all the way through and saw how there could be that information brought on chain through those oracles. And I was looking for more information on those optimizations. I was wondering if you could share. Do you have any readme on those or anything like that? Because I want to see if I could share those out.
Right, I'll just send a link to the chat, which has
Perfect.
the link to the basically our pricing library README, which also has a section for optimizations.
Perfect. Yeah, so I have a few questions here. And anyone who's watching, feel free to drop questions in the chat. I'm happy to ask these Messari devs these questions. I enjoy databases. I enjoy schemas. I think they're really interesting, and you guys work with those all the time. I'm curious if you guys have a process when you begin designing a schema. Is it, after building 150 plus subgraphs, is there something that you guys do beforehand to get into that flow? What are you guys' techniques? What are you guys' thoughts on how you guys conceptualize a schema before you guys start building it?
At Messari, we have many analysts who are always collecting data and producing various reports. So internally, we have basically a lot of internal knowledge and experience about what kind of metrics are useful for people. So when we're scoping out a new category of subgraphs that we'd like to build, we reference basically industry standards with other major DeFi players like DeFi Llama, and also internally with our analysts to basically get a picture about what metrics are actually useful, and then based on that, that's basically our guide for building schemas.
Yeah, that really helps to have an analytics team.
Yeah, it really does. Yeah,
That
good thing
is
we
huge.
didn't have to build 150 subgraphs to build like quality schemas off the bat, because we just had so much experience with it prior to starting.
Right. And for those of you who are getting started with schemas, getting to know essentially the purpose of the smart contract is a great start. So understand that purpose of the smart contract, and from there you can start to identify where you should create your entities and how you should really relate them. That's really, really key. Another question, DeFi background. Did you guys have a financial background as well as a software background before joining Messari? Like, tell me about that experience and the learning process of how subgraphs interface with your financial backgrounds.
Right. So I actually have something to say about this. So I've always been a dev, right? So like development was not so much. But before coming into Web3, you think that Web3 development is like something else, right? Which essentially it is not, right? You're doing the same kind of coding, but just the source of data is like entirely different. So you have to get into those details. And I would just like to add to this that if you want transition from Web 2 to Web 3, probably developing subgraphs is the best way to do it. Because while developing into the data, contracts, and not necessarily write contracts, but try to read contracts and understand the data flow and like how the protocols work of all of these sorts. So would definitely recommend if you're transitioning, try it.
Yeah, I can second that. If there's one thing that's in the middle of everything, it's a subgraph. So to understand all the different points that it plugs into, that's really, really key. Front end, back end, chain, database, it's all there. So very cool.
Yeah.
Does anyone else have a comment about that in terms of a financial background, financial understanding? Or
I did not have I didn't have any previous work experience in the finance industry, but I was previously doing analytics and data science, programming software before starting building subgraphs. And yeah, I fell down the crypto rabbit hole just like anybody else, and was learning how everything worked on my own. But echoing what Harsh said, basically the best way to learn might just be building a subgraph yourself. Um,
Yeah, very much so. And I have one more final question here. You guys have built a lot of subgraphs. Any tips for builders out there who have 10, 15, 20 subgraphs that they are working on? Or let's just start with 2 subgraphs. What are some things that you guys have learned in managing these that are skills that you had to learn along the way of just keeping everything in production, keeping everything organized? How do you guys manage that?
I would say reading others' repos and going through other developments, other subgraphs, and going through their source code and reading more about it helps a lot.
yeah, very often too. If
Right.
you're
So
building,
something,
oh, I was just going to say, very often, if you're building a new subgraph, you can find another subgraph that looks very similar or just like it, in the sense that like there's new Uniswap v3 forks being deployed. There's many Uniswap v2 forks that have been deployed. There's many variations of Compound and Aave that have been deployed where they all share a common code structure. So one thing that could be really helpful to get you off the ground building like a brand new subgraph is to look out there and see what else has been built, because very often you can find a subgraph that um, is built over a protocol that has a very similar smart contract structure, and doing that can be a really good learning experience, because building like a fresh subgraph from start can be very daunting. But if you have like an example that you can tinker with and modify to start with, that can be a really great way to learn.
Yeah, that's exactly how I learned. Actually, I remember years ago, I only heard about CryptoPunks. I was like, I want to get that data. So I remember finding a subgraph that went to CryptoPunks, and I found also spinning up a basic subgraph, and then both index the same smart contract. And then I was comparing a more advanced extended subgraph to a more basic one, and that was a huge part of my learning, seeing the techniques used in a more advanced subgraph and also the more basic CLI.
I'll extend one more point, and then Drew, you can continue on. But since we've been building subgraphs for 2 years, like the very first subgraphs that we built borrowed heavily from ideas and abstractions that were present in existing subgraphs. I think the first one that we built for our subgraph standardization effort was Uniswap v2, which I had built, and Uniswap v3, and these were like some of the biggest and best subgraphs out there. And a lot of the patterns and helper methods and functions that were used in these subgraphs kind of maybe not exactly carried through, but they carried through into our subgraphs and the patterns that the patterns and abstractions that we follow when we build subgraphs. So it can also be really helpful to look at other subgraphs to find these kinds of like helper methods, helper functions to help you to handle, create, and update entities in the graph database.
Yeah, I love that. Yep, there's so much information out there for subgraph developers, and so many amazing subgraphs to gather. Just observe and see what. For those of you watching, see what these guys have built with Messari subgraphs. I mean, they are fantastic. You guys are really good. I'm going to give you all the credit here, because the amount of thought and effort into your subgraphs and the standardization of those schemas makes it so much easier for people to build on the graph. And so just thank you for the countless hours you guys are really putting in. It's just amazing work what you guys are doing. And I'm going to shift over to a question, open question, last question. We're about to go into a core dev meeting in the graph. So for those viewers out there who are wanting to understand kind of the future of what is coming for subgraphs, the core dev meeting is going to be here. I'm actually dropping that in the chat, so please, on the hour, hop in there. They're going to be talking about a few new Subgraph features. One of those is Subgraph composability, where Subgraphs essentially can power other Subgraphs, and we can start stacking Subgraphs on top of each other, which is super, super cool. And I want to ask you guys, as Subgraph developers who've been really pushing the boundaries of what Subgraphs can do, what features, if you could ask for any feature for a Subgraph to have, what would you like a Subgraph feature to be? What would that feature be? And I'll go around the horn. Chris, Dhruv, and Harsh. This will be the last question for all of you, and then we'll send it off there. Something that you'd like the Graph Node team to hear. I would like this to be happening.
Well, you guys have added like a lot of really really impactful features recently, like being able to preemptively index all of the RPC calls in advance in parallel, and that has been that can be a very helpful feature for us because our subgraphs rely on USD prices to derive many of our metrics. And the best avenue for actually attaining these prices is through RPC calls. And the fact that RPC calls have a tendency to like slow down subgraphs more than anything, the fact that we have this feature available can substantially improve the indexing speed of certain subgraphs to the point where previously they made like deriving certain metrics may not have even been possible, and now they are. That doesn't really answer your question fully. However,
that's a great answer. I mean, you're happy with the feature that was that has these in parallel, which is great. Yeah.
Mm-hmm.
Awesome. Yeah, and they're always looking for more ideas about new features, about new things from builders out there. So if any builders out there are curious, feel free to reach out curious about an idea they have about a new feature that could be built as subgraphs. Go ahead and reach out to me. I'm happy to relay that to the Graph Node team, and then from there we want to make the experience as clean and helpful as possible to dive into blockchain data. So Harsh, Dhruv, you guys pretty happy with subgraphs features right now, or are there any that you really are dreaming of someday?
So I would say there were a couple of things that we weren't so happy about in the beginning, but then you guys got streaming fast on board and then added substream powered subgraph, so that solved all the delays and the multi-chain threading. Um, uh, so those things are sorted out, and now the recent features about uh, the adding chain link triggers into the subgraphs, which makes it like really cool improvement. And now there's like subgraph composability, so it just keeps adding on and getting better. So yeah, here for the tech.
All right, 2 shout outs to the Graph Node team. Home run so far.
Yeah,
that's great. All right, well, Harsh, any wishes for you, or are you pretty happy with the developer experience building on subgraphs and substreams?
I think I don't have anything to add here because we already have most of the tools that we need to actually build subgraphs, and the UI UX for building a subgraph is pretty good right now. You don't need to do anything. You can pretty much build a subgraph from the CLI. Just using the CLI, you can init a subgraph or a Solana substream also, which is pretty cool. I think there's nothing much for me to add here.
Awesome. I'm gonna absolutely ping the PM and tell him that I asked this question. He's gonna be very happy with that. So with that being said, thank you so much for your time today, Chris, Harsh, Dhruv. Thank you for putting in the time, also building so many subgraphs, substreams, doing the work to help Web3 get its blockchain data in a decentralized fashion. That is a huge, huge asset to the entire ecosystem. So with that being said, is there anything else you guys would like to say in these last few minutes before I encourage people to go to the core dev call?
Yeah, just one last thing. So we are open source, obviously. So we accept all sorts of collaboration. So if you're a subgraph builder, head on to Messari /subgraphs, look for bugs to fix or adding new subgraphs. if you're a protocol, write to us at Messari / there's some collaboration link, but yeah, write to us there and ask for collaboration. Yeah, that was my final note.
Perfect. Perfect. All right. Well, thank you guys so much for your time. And viewers who are watching, thank you for your time. We'll see you next week on next week's Graph Builders Office Hours. Have a good one. Chris, Drew, Harsh, stay in the audience so we don't lose the video. But everyone else out there, take care. Have a good one, guys. All right.